In this video, we're going to run through 3 basic set operations. Specifically, we're going to be considering unions, intersections, and complements. So the first thing I have listed on the screen, this AUB, that kind of fancy looking U, stands for union. The union of two sets is all elements that are in set A or set B. So this is all elements that are in one set or the other. The second operation I have listed on the screen with the upside down U is the intersection of two sets. This would be all elements that are in set A and set B. So for an element to be in a union, it can be in one or the other set. For an element to be in an intersection, it has to be in both sets. Finally, that AC, that stands for the complement of set A. So the little c means complement, and that refers to elements that are not in set A. So let's see how these operations work by doing an example. Now, in these examples, it's often helpful to define what we're going to call a universal set, and we'll always denote our universal sets with the letter U. The universal set is all of the elements that we're going to consider in the problem. So every letter in this case that we care about is in the universal set. So the universal set for my example is the letters A through H. So we only have to consider those letters when we're doing these problems. Let's see, set A is the letters A, B, C, D. Set B is the letters B, D, F, G. So I'm going to start by finding the first thing on my list. I'll circle it here, this A union B. The union of two sets is all letters in either set. And so I would start by just listing the letters in set A. They're right here, A, B, C, D. And then my union is also going to contain the letters in set B. So set B contains the letters, let's see, B, D, F, and G. I don't have to write, and I shouldn't write the letters B and D more than once. Because those letters were in set A, I don't write them down a second time, but I do include the letters F and G, and that's the union of those two sets. The intersection of sets A and B, which is the second thing on my list, would be the letters that are in both sets. And so there's only two letters that appear in both A and B, and that would be the letters B and D. So there's my intersection. Frequently, we think of unions with the word or, elements in one or the other, and we think of the intersection with the word and, elements in both A and B. Finally, my third example is asking us to find elements that are not in A and, that's my intersection, and in set B. And so in this case, you might be able to kind of just look at it and look at set B. So here's set B. Which elements are in set B and are not in set A? Well, that would be the letters F and G. Those are the letters in B that are not in A. And so that's my answer. For some people, it might be helpful to do this as a two-step problem. You could actually write out the complement of A. So the complement of A is every letter in the universal set that is not in set A. So if our universal set is the letters A through H, and set A is A through D, then the letters that aren't in set A would be E, F, and G. And then finally, we would take the intersection of this complement, so I have my complement written down in red, so take the intersection of that complement with set B. So which letters are in both of those sets? That's just the letters F and G. All right, let's do one more example. This time my universal set is the numbers 1 through 10. I'm going to define set A to be 1, 3, 5, 7, 9. Set B is 1, 2, 3, 7, 8, 9. And set C is 2, 3, 5, 10. So we can go ahead and do the same thing. If we want to find the union of those sets, I start by listing all of the letters in set A. So let's see, set A contains a 1, a 3, 5, 7, and 9. And then I add anything that's in set B. So B is a 1, 2, 3, 7, 8, and 9. I personally like to put my numbers in order from smallest to largest. It makes it easiest for me to read the problem, but you definitely don't have to do that. You can list your elements in any order that you want. If it makes more sense to you to list them in a different order, there is absolutely nothing wrong with that. So moving on to the second example, now I have the complement of an intersection. And when we're doing set operations, just like when you did order of operations when solving arithmetic problems, we're always going to work inside the parentheses first. So to solve this problem, the first thing I'm going to do is find A intersect B, because that's what's inside the parentheses. So which numbers are in both A and B? That would be the numbers 1, 3, 7, 9. 1, 3, 7, and 9 are in both sets A and B. So I did the part in the parentheses first, and then I'm going to apply the complement to that intersection. So what that means is I'm going to look at my intersection, which I have written down in blue, and then the complement of that intersection is every number that's in the universal set, but not in my intersection. So let's see, the numbers that are missing would be 2, 4, 5, 6, 8, and 10. And that would be my final answer. Now if we move on to the third problem, notice now there are no parentheses. So this time we are going to start by finding the complements. Complement of B, complement of C. We're going to do that part first. And then we'll take care of our union. So the complement of B is every number that is not in set B. So that would be the numbers 4, 5, 6, and 10. And the complement of C, the numbers that are not in set C, 1, 4, 6, 7, 8, 9. Finally, I'm going to take the union of those two complements. So I'm just going to list everything in those two complements. So let's see, complement of B is 4, 5, 6, and 10. And then my complement of C is 1, 4, 6, 7, 8, and 9. And that would be my final answer. Finally, in our third problem, we have A union B intersects C. And once again, we have to work inside the parentheses first. So I'm going to do this as a two-step problem. I'm going to start by finding B intersects C. So which elements are in both sets B and C? The only numbers that both of those sets share, it looks like, is 2 and 3. Yep, 2 and 3. So the intersection of B and C is 2, 3. Then to finish this problem, I'm going to take the union of that with set A. So my final answer contains my intersection, which was 2, 3. And then I also have to add any numbers that are in set A. So I do also need the 1, the 5, the 7, and the 9. So final answer is the set 1, 2, 3, 5, 7, 9. All right, that was my last example of these set operations. We'll expand on this idea in the next section.